The objective of this lesson is to use ratio reasoning to create a new puzzle with different measurements than the original puzzle. This task is meant to be completed as a small group task in which students will work together to find solutions and justify their strategies and solutions to their team members. Previous lessons in this chapter presented various strategies that students might use. To begin this task, we practice writing a decimal as a fraction in simplest form. 25 hundredths as a decimal can be written as 25 over 100 as a fraction. The simplified form of 25 hundredths is 1/4. We know this because we know that 25 cents is 1/4 of a dollar. 50 hundredths as a decimal can be written as 50 over 100 as a fraction. The simplified form of 50 hundredths is 1/2 or 1/2 of a dollar. 75 hundredths as a decimal can be written as 75 over 100 as a fraction. The simplified form of 75 hundredths is 3/4. The second step in this activity page is for organizing class groups. Working in groups of 4, students will write their group names in the table and assign each person at least 2 pieces using the letter names, making sure all 8 pieces are assigned. The third step is for groups to work together to create a new puzzle. The line segment that is 2 units in the original puzzle should be 5 units on the new puzzle. Each person will create and cut out new puzzle pieces using grid paper as was assigned in step 2. When all of the new pieces are made, groups will work to put them together to assemble a new rectangle. The ratio of the original puzzle to the new puzzle is 2 to 5. As we fill out the table, we divide both 2 and 5 in half, getting 1 unit to 2 5/10 units. Each of the unit lengths in the original table will be multiplied by 2 5/10. The ratios continue: 3 to 7 5/10, 4 to 10, 5 to 12 5/10, 6 to 15, and so forth. Now we can use these numbers to determine the new lengths of the sides for our puzzle. Before we do this, we can write in all of the lengths of the sides that are not listed. If the full width of the rectangle is 12 units, the missing side on the bottom right-hand triangle will be 6 units. Along the right-hand side, we can see that the missing top edge has a length of 2, similar to the length of the rectangle directly across from it. Therefore, the total width of this rectangle is 8 units. Along the left-hand side, the missing length would also be 2 units. The other sides can also be filled in using deductive reasoning. Once all of the puzzle sides are determined, we will look back onto our ratio table to see the corresponding value for each side. All lengths of 2 units will become 5 units. Lengths of 1 unit will be 2 5/10 units. Lengths of 4 units will become 10 units, and lengths of 6 units will become 15 units. Other lengths can also be determined by the completed ratio table. We can now draw a larger puzzle piece on our grid paper using the new measurements. When we cut them out and work together as a group to assemble a new puzzle, we will discover that it still fits neatly as a larger rectangle. Students who are ready for a challenge can try this same activity again using larger or smaller scales of proportion. Some possibilities might be making a 2 to 3 5/10 ratio, or a 1 to 1/4 unit ratio, or a 2 to 6 unit ratio. The objective for this lesson was to use ratio reasoning to create a new puzzle with different measurements than the original puzzle. We met this objective by making a ratio table that converts each unit measurement into a new measurement and then drawing out each piece onto grid paper to form the new puzzle.